Hi, Darrell Wittenberg here with Industrial Solutions and Ready to Weld. And I wanted to show you some features that we've added in our 2026 model of the Ready to Weld pipe spool welding system. I've got Jacob here today. Jacob's new with our team. He's learning how to be a guy that installs and supports and trains people on this equipment. Commitment we make at Industrial Solutions is if we sell it, we support it. So we build everything here that's ready to weld. We design it, we do the code, we do the fabrication, all the engineering. We even build the electrical cabinets here. The other thing we make a commitment on is we're going to have dedicated staff to supporting this product. So Jacob's going to be running the system today, and Jacob actually holds in his hands one of the things that's a new feature for 2026. This is our remote pendant. Notice it's wireless. It's something that a lot of clients were asking us about. They were wanting to have a system that gave them the freedom to not be tethered to a wire for the remote. And so this gives you that option to where you can go all over the system without having to drag a cable with you. And it allows you that flexibility. A lot of our clients will even use this while at the operator console because this is a really nice, compact way to operate the system. But if you also want a wired remote, we still offer it as an option. So if you've seen our demonstrations in the past, this is our standard wired remote. It is an option with every system. You can order both or one, depending on which way you would rather go. This is a good backup because with a wireless remote, you have a battery. If someone forgets to charge the battery, then you could use this, still operate until that battery charges. So it is a good backup. A couple of other features that are new for 2026 is shown right here in this portion of our system. You'll notice that our torch is tilted back. We have a motorized drive that is programmable that allows you to set a lead and lag torch angle for your welding. By being able to tilt this direction, it gives us a better entry angle for the wire. On MIG welding, we can have two torches mounted. So right here we have our routing torch, and normally you're going to run an 035 wire here. And then we have our fill-in cap torch. Notice that they're not at the same angle. One is giving you a little push, the other one is giving a little drag. The idea being when you put in your roots, you want to drag that arc, and whenever you're doing your fill-in cap, you're going to want to push. And so these are already set up at an angle that works well for that, but then you can also adjust that angle if you want to change that for a given weld. Another feature that's shown here on this is the standard 2 or double wire feeder system. Every system now from Ready to Weld is going to come with 2 MIG wire feeders. You could have one set up for routing. You may want to run, like I said earlier, 035 wire for your root. And then you could run the other one set up for flux core, metal core, or solid wire, maybe an 045 solid wire. That allows you to have both torches set up, both wires set up, and you don't have to change things in between on the welds or going from pass to pass. Makes it much faster, much more efficient. So this now is standard, and this torch tilt is standard. The other thing that is going to be standard with our system is this ability to do a socket weld. Not all of our competitors in this market allow you this functionality. Simply by releasing this clamp, I can tilt that entire torch assembly, all of my slides, both 45 degrees for doing the backside of a slip-on flange, let's say, and for doing the ID of that slip-on flange. So this is really handy from that perspective. Another feature that's really nice that we've added to the system is we actually have more axes of motion for you to have control over than anybody else in the market. Right here we have a pendular oscillator. That's going to be like walking the cup. That is what is driven by this motor, and again, it's programmable. Then right above it, we have our horizontal or steering actuator. This slide gives you the ability to steer right to left without changing your oscillation parameters. So it gives you right-left adjustment on the weld, and it allows you to keep your oscillation parameters exactly where you want them. Let's talk about a real-world situation for that. Let's say that when someone puts the joint in the chuck, they're just a 16th out or even less. At the chuck area, that's not a big deal. But when you get out 20 feet, 40 feet from the chuck, all of a sudden, that part is no longer spinning in a circle, it's an ellipse. And your center line is going to move right to left a little bit. We're the only ones in the industry that give you this cross-seam adjustment for fine-tune adjusting while welding, but not adjusting your oscillation path. So it's really critical that that's there. The other slide that we offer you on this system is a vertical adjustment. What that's going to do is it's going to sense that arc gap. On the TIG mode, we're going to sense that through the voltage. While we're welding in MIG, we're going to do it through the current. We all know that pipe's not round, so as it rides through that ovality, that torch is going to rise and lower automatically by sensing it through the arc. That's what this slide gives us. So again, we've got torch tilt, we have pendular oscillator, we have cross seam adjustment, and we have arc length control, all programmable, all controlled right here on this front end. That's all standard on a 2026 model of the REDI2WELD system. In this system that we're looking at here, this is a system that's destined for a home in New Jersey. And so what we have is what is our most popular setup, where we have a headstock on both the right and left side. So Jacob, if you would, go ahead and raise that torch up a little bit, and we're going to rotate this column to show you how you would operate this in the field. So he's going to raise that boom up a little. And now we're going to rotate this around. We can adjust this speed. We deliver this at a speed that your safety folks will love. If you want to adjust that speed and increase it, we will show you how you can set that speed at a different level, but it's at a very safe speed so that no one's caught off guard by it. They would simply rotate this around and strike off on that other headstock whenever this weld is done over here. That allows you full function where you can be welding over here, loading and unloading over there, getting that one ready to go. And then as soon as you're done welding on headstock A, you simply rotate around to headstock B. Makes it very simple, makes it very efficient, and allows you to keep that welding efficiency at a premium level. So he'll rotate that back around. The other thing that I want to show you is our cart travel. We are unique in this in the fact that we're the most flexible of anybody in this market. If you want two headstocks, you can set them up this way, or if you want to have two headstocks where they're facing each other, I could put another one right here. If you wanted four headstocks, two on this side facing this direction, and then two behind me, just like these are, facing that direction, we can set it up that way. If you wanted 8 headstocks, we can set it up that way. You can add or subtract headstocks at any time when you own our system. We're unique in that, in the fact that we want to give you ultimate flexibility with where you're at today and where you hope to be in the future. This whole cart travels the length of our system here. That gives you the ability to stretch this out to a double random length on this side. We could also do a double random length going back that direction. So you could have, like I said, up to 8 headstocks with one welding component. It's very flexible. On this system, we have MIG and TIG. This is my TIG power source. It is a 350 amp, 100% duty cycle EWM Tetrix 352. This upper section is my power supply. This section is my hot wire. And then this section is my water cooler. 100% duty cycle at 350 amps. We can go up to 600 inches a minute of wire with this system on the wire feed. On the other side of the boom is where I have my MIG power supply. That is an EWM Phoenix XQR 552. What that tells you is that it's going to have 550 amps of power, 470 amps at 100% duty cycle. It has 2 wire feeders, and it also is a water-cooled system. That water-cooled system lets me run all day long without stopping. We can put on this cart bulk feed for our wire, So if you have high production, we can put a 500-pound drum of wire on this cart, and it's designed to let you keep going all day long. Last but not least, on this cart, we also have another cooling system. That is for our camera. This is our camera system. It's a Cavatar camera system. The one that we're showing you today has a cooler on it that is allowing us to, again, run at 100% duty cycle. The Cavatar system is also capable of reading the joint geometry. And what you will see in a subsequent video to this is our new REDI technology. REDI will allow you to have this system set so it's reading that open root or closed root and tracking the seam. So as that root opens or closes, it makes automatic adjustments to the system so that it slows down, speeds up, narrows the oscillation, widens it, adjusts the wire feed speeds, all of those things that a welder would do without thinking. The system's going to interpret that and do that for you. Today, Jacob's going to be doing some steering because we're not running REDI on this yet. That'll be on a subsequent video. On our headstocks, these are the 2026 version of the headstock. These are really, really impressive systems. You can see here that we have a vertical adjustment for our center line that is powered by this motor down here. This system gives you the ability, as it sets, to rotate a 36-inch long radius elbow with a flange on the outboard side. That is the amount of stroke we have on that center line adjustment. That is controlled at the headstock and on the remote pendant and at the control panel back here. We also have on this the ability to purge through the chuck. So that's a great feature. So while I'm setting up over here on this next joint, if I were doing stainless and I'm purging the ID, I can go ahead and turn my purge on that other headstock while I'm welding over here. By the time I'm done here, that side will be fully purged and I can strike off. Again, keeping that efficiency where it needs to be. Another great feature of these systems is our rotary ground. That actually hits on the back side of that plate. There's no cables dangling, there's no cable wrap you've got to worry about. We have a solid contact to that back plate, so you're getting your ground sense through that system for the arc. When I talked earlier about being able to adjust automatically for ovality, that's where we're getting that sensing from. We also have safety pins in here that lock us into place. So once you get it to the height that you want, you simply put the pins in and we know that we're safe and secure. Last but not least, in front of each one of these headstocks, we don't have it set this way in our shop, but you would have track and 4 pipe supports that are standard with each headstock in a ready-to-weld system. So this track would ensure that your pipe supports are in line with the center line of the headstock. We have 2 short ones and 2 tall ones. There is some overlap between them, but essentially what we would tell you is if you're doing 24-inch and above, you're probably going to use the shorter supports. And if you're welding 24-inch and below, you can use the taller supports to keep that center line where you want it. That covers all the basic features of the system. I think we're ready to weld. Jacob, are you ready?
Ready.
Okay, so we're going to go back here and we're going to show you the operator console. So on the operator console, you can see that Jacob can see everything going on in the weld. He's going to steer, go ahead and adjust that over to the center line a little bit just so they can see what happens when you bump it over. He's aligning himself with where he wants to strike off. And then this is our operator screen here. Would you take it to the schedule on the screen? So this shows you all the parameters that we put in on this. If you're familiar with orbital technology, we set this up to be something that would be very similar to programming an orbital power supply for orbital welding. It's very straightforward. It asks you very simple questions and allows you a great deal of control. So Jacob's going to be running the weld, but what I also want you to see on our control panel is up to the left we have 2 regulators. When we're purging the ID of those pipes, when I told you we could purge through the chuck, those 2 regulators up there to the left control the flow of that purge on the right and the left-hand side headstock. Okay, I'm going to go over here. Jacob's going to strike off on the arc, and we'll talk you through this weld. So this is a 6-inch Schedule 40. We have actually prepared these coupons using our Watt Specialties pipe profiler. So we're the only company that I know of that rents that technology, and we took one of our rental units and we prepared a bunch of coupons. The only thing that we do that's a little unique, just because we don't want to flapper wheel all of them ourselves, we send them off and get them sandblasted. But these are as cut off of the Watt Specialties 244. So with that torch tilt, we're using the EWM root arc technology. It's a modified short circuit process that allows us to have a very forgiving root arc process, and it allows us to have that variation in that opening. We still have a soft arc. It's still not pushing through. What you will notice on this is when we take a look at this root, Jacob's numbers are actually probably equivalent to a root and a hot. So on this pass, we're going to almost flush it out just on the root, and he's going to transition after this pass to a fill cap. What we found when we added this torch tilt feature, normally we were traveling at about 3 inches a minute on the root pass for this weld. That was when we were coming in almost at 12 o'clock and our torches were vertical. By allowing that torch tilt, we were able to increase that speed by 40% on the root and 50% on the fill passes. Much more forgiving and allows for much more speed. So looking at the ID, again, we're consuming the toe of that bevel and we're getting reinforcement on the ID. You'll see as he comes across this tack that's coming up, we feathered down the tacks and then we just reconsume them. We don't have to do anything special when we hit the tacks. We don't have to hit a button and let it know it's hitting a tack. We simply ride through it and consume that tack. So we're coming up on that tack right now. As we ride through that tack, it's reconsuming it on the inside. The tack's, for the most part, no longer really visible. You can't really tell where it was. And it just keeps welding as it comes off of the tack. Another feature I didn't tell you about earlier is that we have multiple solenoids on this system for our gases. For our root, we're running a 75-25. For our fill and cap passes, we're going to run a 90-10. In the system, we tell it which solenoid to actuate so that it puts the right gas in the right pass. So right now we're running a 75-25, and it is pulling that, it is putting that gas in. We are also running a fume extraction system on this. That is an option that's on this torch. It's right here. We run the hose through the cable track so that you can pull all the fume from this weld. So you'll notice up here, there's not a lot of smoke coming around. It's a very clean weld. This becomes even more critical if we were doing a high chrome or a stainless weld. We want to make sure we're mitigating all that hexavalent chrome that we can. So we just came off that last tack and we're on that last corner of the pipe for our root pass. Going back here, taking a look at what Jacob's doing, you'll notice, you can see Jacob there, he's not overly active. The system is allowing him to just weld right through that open root. He's got a very clear vision of the weld. And the system will automatically stop when he ties in. So we're coming up on our tie-in right now. So we do the tie-in. You'll notice that it changed its sequence just a little bit at the end. That is to keep us from having a cavity whenever we do that tie-in and turn off the arc. He's going to rotate that around a little bit because we wouldn't want to start our fill and cap at the same spot. And whenever you're ready, Jacob, let's go ahead and do that fill and cap. This will be an oscillated fill and cap pass. If you wanted to run stringers, that is fine. We have the capacity to run stringers as well. So we're going to be using a process called force arc from EWM. And what force arc does is it really controls the heat input and makes it very directional. So we get great sidewall fusion with our weld. It allows us to increase speed and really control that arc. We'll take a look at the program back here. Jacob, can you take it to the program speed? So right here, we're going to take a look at pass 2, and we are programmed to run a current of 200 amps, and our wire feed speed is 275. Now that's on 045 wire. We are traveling right now. What's our rotation speed? 10.5 inches per minute. We can run faster, we can run slower, depending on what you're wanting to do. If you were running stringer beads, we would have an increased speed on that rotation as well. So it's really flexible on what you want to do. If you would, take it to the operator screen. This is the screen you're going to see while you're welding. You'll see here that we have a percentage complete. That's telling us where we're at on that particular pass. And then when we go down here to the left, we actually have the heat input being calculated. All of this data can be captured and saved, as well as we can capture and save the video on this. So it gives you a great amount of control on what you do with that data from a QA/QC perspective. Okay, we're done with that 6-inch weld. That's about as real world as we can make it. That is a root to cap 6-inch schedule 40 done in 2 passes. Our arc time's just a little bit over 6.5 minutes on this weld. So now what we're going to show you is the amount of time it takes to switch from MIG to TIG with the REDI2WELD system. Again, we're the most flexible in the industry. If you buy a system and it is MIG only at the beginning because you just simply don't need the TIG welding right up front, you can add the other process at any time. We have clients who have done exactly that. They may have purchased a TIG-only system because they were doing nothing but Schedule 10 when they originally purchased, and then later on they need to be able to do MIG welding. This allows you the flexibility of adding that other process anytime that you need it. So I'm going to help Jacob out here. We're going to take this coupon off. And now he's going to change the gripper to the size that he needs for, we're going to weld a 4-inch Schedule 10. And we're going to do that 4-inch Schedule 10 in one pass with reinforcement on the ID and the OD. So we build these grippers here at ISI as well. This is a ready-to-weld gripper. It has a range of 2 to 36 inch. Now there's a lot of people building grippers today, so you might wonder, why did you go and build your own gripper? The fact of the matter is we couldn't find one that covered from 2 to 36 inches, and that was the most common size that our clients told us they needed. So I want to show you what Jacob just did there. We have a clamp here that holds that torch. It is simply, this is how it was set up for the MIG. You release that clamp, pull that out, and now he's ready to drop the TIG torch in. And that's all you have to do to switch from MIG to TIG with the ready-to-weld system. Nobody else has as simple a process that allows you to have 2 torches set up at all times on the MIG and then switch in a matter of a minute or so to the TIG process. So what we're going to be welding today on the TIG process is a 4-inch Schedule 10. I'm going to take this coupon and show you that joint geometry real quick. So what we've done is we've actually cut this on our Axe-Air pipe and tube saws. One of the benefits ISI brings to the table on this kind of equipment is we don't just do ready-to-weld. Everything that has to do with round applications for pipe welding, we can help you with cutting and facing and beveling and fit up to help you really get control over that process. So this is a square cut on one side from the Axe-Air saw and then a bevel on the other. We're doing a square to a bevel so that we can replicate a pipe to a fitting. We would recommend on systems like this, square cut your pipe and then tack that directly to your fitting, and we can do it in a 1-pass weld. So I'm going to connect this ID purge to the supplied line. Open up my clamp a little bit. And that's all there is to it. We're going to check to see if I can mount that in there square real quick, because since Jacob's going to have to weld this thing, he probably wants to make sure that we did it right. So back here on the controller, we can turn our gas purge on. And we can see right here our flow rate. So we're running about 30 CFH right there on this flow meter. If we were purging through the other headstock, we would see it reflected here as well. So now what Jacob's going to do is he's going to drive the torch over. The whole cart will shift. And he gets it roughly in place, and then he'll drive it the rest of the way with our cross seam adjustment. So we'll drive the torch down. You can see he's actuating the boom, bringing it out closer to where he wants to be. Bringing the boom down now. And he's ready to go. That's all it takes to go from a MIG weld to a TIG weld. He's going to align that now on a tack. We always recommend striking off on a tack if possible. And then we'll do this weld in 1 pass. It takes about 4 minutes to do this particular weld. Okay. So what we will be doing with this is a pulsed weld. We will have a high pulse and a low pulse. We're not actually going to be oscillating on this one, but we are going to be monitoring that arc gap, as I said earlier. With this slide and through the arc, we'll be measuring the voltage and keeping that at a constant level. There's a dynamic relationship between arc length and voltage. And so we set a voltage value and it tracks through and makes sure that we are consistent there. We will strike this off with high frequency. And again, we're running hot wire TIG. You might hear a popping or a hissing noise in the background there. That is literally just that hot wire TIG. It's essentially breaking that current that we have there, or that connection. With our screen here, I can look through on the ID and make sure that we're getting it on the inside. We're getting a nice root in there with not overly aggressive penetration. And because we simply did fusion tacks on this, because we went pipe to fitting, we didn't have a gap, we don't have to worry about thinning down those tacks because we didn't add any material there. Just over halfway done with the weld at this point. Now we do have clients who will ask us on Schedule 10, can we do an open root? Yes, we can. They ask us if we can do a 2-pass weld. Well, of course we can. But for most of our clients, if they can get positive reinforcement on the ID and the OD in one pass, they would prefer to do so because it is stainless. We want to weld it as cool as possible, and we don't want to put any more heat into this than what we need to. So stepping back here where Jacob is, one of the big features of this system is that, again, it allows us to see the heat input. And we are right now, because of the pulse, we're balanced out at about 16, 17 kilojoules. So we're equally balanced on our pulse rate. So we're spending half of our time on that high pulse, and we're spending half of our time on the background pulse. About 3/4 of the way done now. Another nice feature about these headstocks is, let's say that you needed headstocks for manual stations in your shop. These can be set up to be either integrated with a ready-to-weld system, or they can be manual headstocks. All of them come with a foot pedal that allows you to control them just like you would a manual headstock. And it also, when it's set up in the manual mode, comes with a remote pendant that you would set your speed on. And so the foot pedal is an on-off and bidirectional. The remote pendant is what you would set your speed. If you had purchased these as a standalone for a manual station and then decided that I really want to step into a ready-to-weld, You could take those manual headstocks, we change a couple of positions on the motor control, and we can integrate that right into a ready-to-weld. Okay, that weld is finished. I'm gonna go ahead and take this purge cap off now. And regrettably, we can't really put our cameras inside here, so you'll have to take my word for it. But we are really nice, and we have almost a white weld on the inside. We have really good color, and we have positive reinforcement all the way around on a joint that was closed root, just a square cut to a bevel. So in this video today, we've shown you both a TIG and a MIG weld from root to cap. We've shown you all the features that are on this system that are new on the 2026 model. By the way, if you already own a ready-to-weld and you are watching this video and thinking to yourself, I'd really like to have that torch tilt, or I'd really like to be able to have dual wire feed, all of these features are retrofittable to any system we've already got out in the market. We've shown you the rotation of the column and boom. We've shown you the up and down on the column, or excuse me, the boom, and the in and out on the boom as well, and the travel of the cart. This is the most flexible, most robust system on the market today. We built this in response to what our clients told us that we needed, specifically on these features that have been added in 2026. Please don't hesitate to contact us at Industrial Solutions if you'd like to see a demonstration of the ready-to-weld system. Thank you for watching this video today.